Hi everybody, it's Derek from SparkFun Education. As you can see, I'm not headquarters today, I'm in the shop, and that means one thing: it's episode 3 of our Gator board series focused on these guys and the Gator Science Kit. So let's dig in, check out the boards, and maybe build a project or two. Okay, here we have our Gator board collection. Last episode we focused on the Gator Circuit Kit, which are the combination of these 3 boards. The Gator Color, the Gator Control, and the Gator Starter. If you're interested in these boards, check out episode 2 and we go over that and build a really simple project. But for this one, we're going to be focused on the Gator Science boards. And these boards are all sensors. There is an interesting board, the Gator Log, that we'll talk about in a bit. But these are all advanced sensor boards. What I mean by advanced is that we get a number of different data readings from them and values based on the type of sensor that's on the board. And we can go over those really quickly, and then we'll go over how they communicate with your microbit using the Gator bit. So first up is the Gator UV. So the Gator UV, you get light and, as it's stated, UV radiation. So both of those you can measure as values from that sensor. Second up is the Gator microphone. And this gives 2 different values. It gives a gate, which that you can set on the switch here, a high or low, but that gate is essentially a noisy or not. If it's noisy, it will produce a high or yes. If it's not noisy, quote unquote noisy, it will be a low or false. And then it also gives the analog noise level. What I mean by this is essentially how loud it is in the room. It will not record the actual audio going on in the room, but the amplitude or the loudness of the sound in the room. So a great way for using that is how far something is. If you know the audio amplitude of a given noise, and then as it comes closer and then goes farther away, the Doppler effect, you can tell something moving by you very easily. Or is a bird close by in terms of how loud the chirping is or the noise that it's making. Next up is the Gator environment. And this is actually my favorite sensor because you get a lot out of this single board. You get temperature, humidity, barometric pressure, altitude, which is extrapolated from barometric pressure. You get VOC readings, volatile organic compounds. You get CO2, and that is the equivalency, an equivalent CO2. So this is not an actual CO2 sensor, but it gives the equivalency of what that CO2 reading would be. So you get all of these from this single board. So this essentially is a environmental monitoring board in itself when combined with the Gator bit. The other sensor, moisture, and this detects soil moisture or any other kind of loose material. So this could be moisture in cotton balls, for example, if you wanted to. But most people use it as a soil moisture sensor. And you can insert the 2 prongs and it measures current flow between the 2 prongs. This is actually an analog sensor. So it could be used in conjunction with a microbit by itself. just attaching the signal pin to 0, 1, or 2 on the microbit itself. And we'll cover the difference between what an analog sensor is versus the I2C or the bus that these boards use in a bit. So that's the moisture sensor. These two boards are, I would call, utility boards. This is the Gator log. And what the log does is it allows me to data log to an SD card. So the kit comes with an SD card. I can insert this into the Gator log, and I can actually write data to that card on a regular basis, take that data, that SD card, and go plug it into my computer and do some data visualization analysis in something like Google Sheets or Microsoft Excel. It shows up as a text file, so pretty much any computer can use it, a Chromebook, a MacBook, Windows PC. So that's the Gator log. And then last but not least, I have the Gator RTC. And what RTC stands for is real time clock. And you can probably guess from the name, this allows us to give actual accurate time and date. So it has a small battery on it, so I can actually set the time on the board. I can unplug it and it will run off this small battery for a while. So I don't have to reset the time every single time I use it. It will remember that. It also has, you can see it has a small button as an input. So I can actually use this button on this board to trigger something, maybe trigger what time the button was pushed. If I wanted to be able to map a specific data point to a specific time when it happened. And there's a number of programming blocks that come with that. Now, each one of these boards has its own Microsoft MakeCode package associated with it. So programming these becomes very, very, very easy as long as you know what package you're looking for with the microbit using Microsoft MakeCode. With that, we're going to jump into looking at how to program that. But before we get there, I want to talk about how these get hooked up physically using Gator clips or the banana clips. Okay, I switched out a piece of paper and we're going to talk a little bit about how these boards are hooked up and how they communicate with the microbit through the Gator bit. As you well know and probably understand, the microbit plugs into the Gator bit, and one of the things that the benefits of the Gator bit is that it breaks out a number of advanced communication protocols that we can leverage and that we have leveraged with our boards here. One of them is the I2C or I2C protocol, and it actually is two wires, an SCL and SDA, and SCL stands for your clock signal. If you're a piano player or a musician, you can think of this as your metronome. It's a clock signal that keeps time. And SDA is your data line, so it's the data going back and forth between the microbit and the different sensor boards that we have here. In episode 2, when we talked about the Gator circuit kit, we talked about parallel and series circuits. Our boards here are hooked up as essentially parallel circuits on what's called a bus. Think of it as like how Christmas lights are connected in this modern age, where you have basically a positive and negative, or power, ground, and in this case there's 4 wires, power, ground, and clock and data, that run the length of the entire circuit. And I'll draw this out in a second. And then each one of these, it passes through each one of them. So if, for example, my Gator UV sensor burns out, it's not going to keep the other two sensors from being able to talk to the microbit. It will actually pass in one end and out the other without causing an issue on the board. Hopefully the boards never burn out. They're all protected pretty well against that type of thing for the classroom. But they're on a parallel, and I wanted to just demonstrate that and show that for you because that's an application point of what we had talked about previously. So the way these are hooked up, you can use alligator clips to hook these up. I'm going to just draw lines because it'll keep everything a little bit cleaner and nicer. But as you can see, each of these can be alligator clipped or banana clipped together and create kind of this long daisy chain of sensors. And as you want to add sensors, you can just add one right on the end. It doesn't matter which one comes first, which one's last in the daisy chain. As long as they're connected correctly, we're good to go. So hooking these things up. If you look at this, we use clock and data, or these two bottom ones. And then we have 3v3. So all of these sensors and all these boards use 3.3 volts. That's really important on the Gator bit because you have the option of 3v3 as well as 5 volts. So we want to make sure that we're using our 3.3 volts to power that. And then we have ground, which we can connect to any ground on our Gator bit. I'm going to move the microbit out of the way so it's easier to draw. So starting with ground, I would connect a Gator clip here, and that would connect to my ground here. Grounding, this is the RTC, and this could, again, I could switch these boards up and they can be in any different format that I want as long as they're connected correctly all the way down the chain. So let's put the Gator RTC at the end, and so I have my ground there, and then I would connect ground here, ground there, and ground there. Next is power. And again, we're wanting to make sure that we're not using 5 volts, we're using our 3.3 volts or 3v3. So that comes from here. 3v3 there. Connect, connect, connect. Now these are short. This can be pretty long if we want it to be. They don't need to be a specific distance for this. So if it's a full alligator clip length, or maybe even 2, if you wanted to keep some sensors a distance apart from one another, you can do so. But now we have them all powered and grounded. The next up is my clock signal. Actually, let's do data. My data is this bottom one, and it goes there. Data, data, data. And next up is clock, and I have to cross, so I'll do that, 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 that. So that would be how if we hooked up these 4 boards on a bus. So think of this as this comes in, the ground goes actually through the board, passes through the other side, and then all of the circuitry connects to that through the PCB on the board. So again, these are connected in parallel on a bus. So again, think of a bus as a daisy chain or a street. It's actually a good way to think about it. So we're going to write it up here. A bus is a street. And as I squared C, how that works and how the microbit can tell what's all this different information coming at it from different sensors is that all of these sensors have different addresses. Now in MakeCode, we've pre-programmed the addresses on these boards. So our MakeCode package, our software package, knows that the address for, let's say, the Gator UV or the Gator RTC. You don't need to worry about that, except for if I try to add, let's say, 2 Gator environments on one bus, your microbit will be confused in its programming because it'll be getting different information possibly from the same address. So it'd be like getting two different packages at the same time from the same place, even though it just doesn't work. So we want to make sure that we're not using the same board for any application on the same bus. If you want to have the same reading across, let's say you want to use multiple temperature sensors, I would recommend using two setups and comparing the two in some way, shape, or form. But yeah, we can't have the same sensor on the same bus. And that's how I2C works. Now, hookup for the other two boards. We have the Gator soil as well as the Gator log. Now, Gator soil is a sensor, and we'll tackle that one first. This is an analog sensor, meaning that we can read it on 0, 1 to 8, 16, and I think that those are it. So how we hook this up is it takes a power and ground. So again, I can come off of the end. I can come off of anywhere that's power and ground on these. I can also attach another Gator clip here to power this. So let's move it here. Power goes there. I also have ground. I actually have another ground pin, so I can do something like this. And then my signal pin can go to, let's say, pin 1. And that's how that would get attached. Now, earlier I said you could use just the microbit on its own to measure this or monitor this sensor, and you can do that the same way. So if I was to steal this sensor, let's say power goes to 3V on the microbit, ground goes to GND, and I used pin 1 before, so I'll do the same thing, and I'll do it here. Pin 1, which is Gator clippable before, right there. So I can actually do some soil monitoring with just the microbit itself without the Gator bit. Now, that being said, the one last board is the Gator log. And this communicates over what's called serial. Serial is similar to I2C, but it's a fancy way for multiple devices to communicate back and forth. And serial takes 4 pins as well. We're only going to actually hook up 3 this time because our Gator log is only really listening to what the Gator bit is saying or the microbit saying. It's not actually going to communicate back in this application. So what we're going to do is we're only going to be receiving, and you can see here there's an RX and a TX, power, ground. So we're going to hook up RX, 3V3, and ground. So 3V3, let's just say we're going to go, for simplicity's sake, we'll hook up there. Ground, we're going to come through here and hook up there as well. And RX, we're going to hook up to pin 0. Now in MakeCode, I can program the microbit to transmit data or send data, write data over a specific pin using serial. And we'll do a demonstration of that in a bit around logging some basic data. What we're going to do is we're going to set up the Gator environment and the open log to log some data. It sends that data over this pin, and the microcontroller on here, this black square here, takes that data and writes it to a text file that's going to be on this SD card. And then I can take this SD card out I can take an SD card out and go place that in my computer, and that text file is then accessible by me to do things like graphing the data or doing data comparisons between mine and maybe another student's project. So all of these, I know it looks messy, but we have our I2C bus, which we can just keep adding sensors to. We have the Gator soil, which is an analog sensor. Remember, it can be used with just the microbit it's on its own or the Gator bit. And then the Gator log, which can also be used with just the microbit as well. But it communicates over serial, and we'll do some demo for that later. So that's the hookup, and let's take a look at programming one of these boards or a couple of these boards in Microsoft MakeCode. Okay, we're now going to hook up and build a circuit and a logging device using the Gator bit, the Gator environment board, and the Gator log. I have a microbit with me as well. We obviously need that, a USB cable, battery pack so that we can disconnect everything from the USB cable and go take it and leave it somewhere out in the wild, and then an SD card. The SD card just gets inserted into the Gator log, and it stays there until we remove it to check the data. But we have to hook this up with Alligator clips. So I do color code mine. So I use red and black for power and ground. And then I usually use yellow and green for my I2C data and clock. So we're going to actually hook up the Gator environment first. So I actually start at the board end of things and go, okay, ground, I'll hook that up there, 3v3, hook that up to 3v3 to red, so now I have power and ground. Use data as yellow and clock as green. So I have my bus, my street of wires. I can place that up there, and I'm going to plug in or clip in my ground and my 3v3 as well. Now my yellow is data or SDA, and green is SCL. Now it's time to hook up my Gator log. So the Gator log has RxTX, 3v3 ground, and a reset pin. In this application, we're actually going to be using all of these pins, and I know before we talked about just using the RX, but we're actually going to be using all of them, and we're going to be hooking them up to pins 15, 14, and 13. First things first, power and ground. So I have another set of red and black, so I'm going to hook up 3v3 to red and black to ground. I have two grounds, so I can actually use the second one here. And the open log can share the 3v3 output with, or the Gator log can share it, the 3v3 with the I2C bus with the environment board. Next thing is the hookup of RX, TX, and reset. So I have yellow, white, and orange left. So we can get away with it, except there's going to be a little bit of a repeat here with yellow, but we'll try to keep them as separate as possible. So starting with white, we're going to hook up our RX to pin 15, gray TX to pin 14, and we're going to use the other yellow one as our reset pin all the way over to pin 13. So it looks like a little bit of a mess, but we have RX, TX, reset for the gator log, and we have power and ground for both, and then our I2C, which feeds our sensor, our gator environment board there. Okay, next up, insert our microbit, and we'll actually add the batteries later after we get code onto this, but let's move to that. Let's program this and get a program put onto the microbit.
Okay, we're going to be programming our project now that's using the Gator environment board and the open log, and we're going to build a project and program a project that very simply takes the temperature reading from the Gator environment board and logs that value to a file on the SD card. One of the goals that we're going to have for this is that we're going to be able to control that using the A button on the microbit. So I want to be able to press the A button to start logging, and I want to press the A button again to stop the logging. So in MakeCode, the first thing I have to do when using external hardware, especially the Gator boards, is that I need to add their software packages. Otherwise, I won't be able to program them. So under Advanced, scroll down and you'll find extensions. We're going to click on extension. And there's a number of other file or hardware and software extensions that I can add, but I'm just going to type in Gator to search. Scroll down and you'll find the Gator environment board right here. We'll just click on it to add that. At the time of this recording, the Gator log software package is too new to be able to be searchable. It's not in the search index yet for MakeCode. So we have to do an extra step, and that is in the hookup guide for the Gator log. If I go here and I go to adding the MakeCode extensions and scroll down, we give you a URL where it says search for PXT package. It gives us URL, and we give you a little copy button so you don't have to even highlight it. So we just hit copy. And now I can go back to MakeCode extensions, and instead of searching for log or anything like that, I just paste the URL and enter. And now I have the Gator log package, and I can add that to my program. So if I look at my program, my code block drawers, I have a Gator environment and a Gator log. So we're good to go. So now we're ready to start programming. First things first, both Gator boards need to be what's called initiated. In other words, at the very beginning, as soon as we turn everything on, we have to do some software setup. So under Gator environment, I'm going to initialize Gator environment sensors. And same thing for Gator log, initialize Gator log. So we've initialized both boards, meaning we've started them up. All the background work is going to get done for us, so we don't have to mess around with anything there. One of the things that we're doing with my addition of pressing the A button to start and stop logging is that I need to be able to toggle a variable on that button press. And so we have to create that variable first. So under variables, I'm going to click make a variable. And I'm going to call that variable start stop. I'm going to click OK. Now I have a number of blocks available to me. I'm going to bring in set start stop to, it's a lot of S's, and I don't want to set it to a number, I want to set it to a Boolean value, a true false value. And I find those under logic. And I want to set it to false because I don't want it to start logging right away. I want it to be false, or basically start with the light switch off. Perfect. Now, the button press. Under inputs, on button A pressed, we want to toggle that start-stop variable. We want to be able to take that variable and we're going to reset it to something else. We're going to set it, it's going to sound funny, but we're going to set it to whatever it's not. So right now it's set to false. We want it to set to true. So we're going to say logic set to not start stop. It's a bit of hard logic to play with or understand, but set this to whatever it's not. You can only be done when you have a true false. So that being false here, once I press the button, it says not start stop, which is true. If I press the button again, it would be whatever not true is, which is false. And so we can set that back and forth and toggle that variable. Move these up here. So now we need to build our actual logging system in the forever loop. We do that by using first an if statement. And this if statement is going to look at this start stop variable. If this variable is true, we want it to log that data point, else we don't want it to do anything. So if it's a false, it just sits there, it doesn't really do anything. So we have to build this statement, and we have to check that variable using a comparator. We use kind of this equal block. So if two things were equal, we do this, else we do whatever's in here. We're going to compare our start-stop variable, and we want to insert the true logic block in here. So if start-stop is equal to true, meaning we've pressed the button to start things, we're going to give a little bit of visual feedback. We're actually going to show an icon of a checkbox. And then under Gator log, we want to be able to open a file. We're going to open a file named temp.txt. Now, this is not a temporary file. This is temp stands for temperature. And we have to get a file extension, which is .txt. So when this is true, open file name. If this file doesn't exist, this block will create the file for us. Once that file is open, we can then log to it or write to it. And so we are going to write line to current file. And write line receives only text, so we can't put a number in here. We have to convert whatever number of temperature that we were getting from the environment board to text. So underneath advanced, there's a text drawer. We want to say convert to text. And that receives a number of some kind. That number block will come from our Gator environment block. And we're going to use degrees Fahrenheit. So right now, if we ran this, this would be writing a lot of text very, very quickly. It would show that check mark, open that file, write it, and then start over again if we hadn't pressed the A button. So we need to slow it down a little bit. What we want to do is we want to have a 5-second delay between when it writes the file and when it writes that file again. It repeats itself. So we're going to use the pause block right underneath this right line, and it takes a number of milliseconds, and 5 seconds in milliseconds is 5,000. And there we are. This is if it's true, meaning we want it to be logging. Else, I want to give some other visual feedback that it's not working, and I'm going to use another icon and just show an X. And there we have it. There's our program. So on start, I initialize both boards. I set my start-stop block to false as a starting value. When I press that A button at any given time, it's an event, I will toggle that true-false. So it'll go from false to true or back to false. And then in a loop forever, I'm constantly checking that variable if it's true or not. If it is true, I show a check mark icon. I either open or create the temp, again, temperature file, .txt. I write a line of data to that file, which is in this case the degrees Fahrenheit, wait 5 seconds, and then check the if statement again. If that if statement is false, we show an X and we don't log anything. Whew. Last step in this whole process is for us to download this to our microbit. So what we're going to do is we're going to click download. And this file will download to I'm going to show in Finder. And as you can see, I have a lot of stuff on here. Our microbit untitled 12 is the newest file that I've downloaded. And I'm going to click and drag that to my microbit drive. It's copying, and it's on the microbit now. Let's go over and check out how it works with the project.
Okay, as you can see, the code's on the microbit. I have an X showing up, meaning that it's not logging. And you may hear some really high, if you got some good ears, you might hear some high pitch frequency if you don't have a battery pack hooked up. But once I hook that battery pack up, everything should quiet down. Everything's being powered correctly with the battery pack. Now once I click the A button, we should see some lights blink on the open log, or the Gator log, which is telling me that it's logging data to that SD card that's inserted. And it'll be reading that temperature from the temperature sensor or the environment board, doing all the programming that we did on the microbit, and then logging to that file. So here we go. Press the A button. I get a check mark. See a blue LED blink. Be about 5 seconds, and then it'll blink again. So every time you see that blue LED blink on, that is data being written to that SD card. And we're going to wait a few seconds, and then we're going to go back over to the computer and double check our work to make sure that we're getting data onto our SD card. One thing while this is logging is that I know that this seems like quite a wire mess. And one thing that I like to do is I like to be able to, you can either A, braid some of these wires together, if your students know how to braid, or you can get some twist ties, or even some of those sandwich bag clips. It's a really good way to reuse them and be able to clip some of these wires together. So all of the wires for the environment board, clip them together, or even just use some twist ties. And then all of the wires for the open log, again, twist those together so that it's easy to figure out which wires are for which board. With that, I think we've done enough wasting of time. Let's go take out the SD card. So I'm actually going to hit the button again and wait till it shows an X, which means that it's no longer logging. And now it's safe for me to press on the SD card and remove it. And I'm going to go put it in my computer. Take a look at it.
So I took the SD card and I inserted it into a card reader on my laptop. You can see there's a lot of drives, devices that I have plugged in right now. I'm going to click on No Name, which is the SD card that I just inserted. And you see that there's a log000.txt that gets created as a default file. But we want to look at this temp.txt file. So I'm going to double click on that. And you can see right here, in the time that it took for us to talk, we actually logged some data points. So the temperature went from 67.83 blah 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 up a bit, to 68.05, and then 68, and so on and so forth. So a great way to be able to take this data and actually do something with it is import this text file as a CSV into something like Google Sheets or Microsoft Excel. And we've done a number of tutorials and blog posts and another webinar about how to visualize data. But I'll let you look for that. Maybe we'll add it to some of the links on the video. But right there's a good demonstration of, one, how to hook everything up with the Gator bit and the Gator board system, and then be able to log data to an SD card for later. Hopefully in the future we'll be able to explore other boards, other projects, even piping data live over USB cable.
So with that, I want to thank you so much for spending the time with me today, learning a little bit more about the Gator boards and the Gator Science Kit, and how to use the Gator log to log data from one of the sensor boards, and how to get everything hooked up and programmed in Microsoft MakeCode. If you have any questions, please reach out to us. We're always more than willing to help. Also, all of the boards in the kit have a hookup guide. So all of the stuff that I've done here came directly from our hookup guides, with a little bit of extra coding here and there in terms of the button press side of things. But how to hook each and every board up, how to program it, how to find those MakeCode packages are all right there. So again, if you need help, check out our hookup guides for the product. But if you need a little bit extra help, feel free to reach out either on Twitter or through email. So thank you very much for watching this show or watching this episode, and hope to hear from you soon. Talk to you later.